Eric's post makes CubeSandbox look almost unreal. Under 60 milliseconds to start. Roughly 5 megabytes of overhead. Thousands of sandboxes on one machine. The important part is not just the raw speed. Tencent is packaging those numbers with MicroVM isolation, an E2B-compatible API, and a real open-source repo that already ships working demos. That combination changes the pitch. This is not just another agent sandbox wrapper. CubeSandbox is trying to collapse the usual trade-off between safety, cold start, and density. The official docs and charts all point in the same direction. Dedicated kernels, fast startup, low base overhead, and a drop-in path for tools that already speak E2B.
CubeSandbox is an instant, concurrent, secure, and lightweight sandbox platform built for AI agents. Every agent task runs inside its own dedicated MicroVM, a fully independent kernel with complete OS-level isolation. Cold start in under 80 milliseconds, memory overhead of just 5 megabytes, instant startup with minimal footprint. 3 independent security layers: compute, storage, and network. Ensure every thread is intercepted before it can escape the sandbox. Already using E2B. Just swap one environment variable. Your existing code runs on CubeSandbox with 0 changes required. CubeSandbox is open source. Welcome to star us on GitHub. Next, let me guide you step by step on how to install and experience CubeSandbox. Firstly, you need to prepare a bare metal server that meets the requirements. Then run this command to complete the installation. Just wait for a moment, and the standalone deployment will be automatically completed. Next, follow the commands in the CubeSandbox example to create a sandbox template. Use the job ID to wait for the template creation to be completed. The backend will download the image and create a sandbox snapshot. Firstly, you need to set the template ID in the environment variable file. Next, run the script to create a code interpreter sandbox. Then execute Python code within the sandbox, and we can see the output of the execution results. Sandbox pause and resume is one of the important features of Cube. You can save the state of a running sandbox to disk and destroy the VM. Then, after waiting for a period of time, you can resume the running state of the sandbox. The program inside can continue to run. The CubeSandbox provides the ability to control inbound and outbound network policies. You can freely configure network isolation for the sandbox. The above is a brief introduction to CubeSandbox. Use CubeSandbox to empower your agents now.
This benchmark clip is the cleanest proof shot in the pack. The title card says concurrent performance testing, then the dashboard settles on the single creation run. 100 successful creates out of 100, average create latency just under 50 milliseconds, and the P95 still in the mid-50s. That makes the startup claim feel grounded instead of decorative marketing. And because the run is shown live inside the workspace, you can watch the report finish instead of trusting a single static chart. Under the hood, CubeSandbox keeps the surface area surprisingly simple. Cube API gives you the E2B-compatible entry point. Cube master schedules work. Kubelet manages sandbox lifecycle on each node. Cube proxy routes requests into the right instance. CubeVS applies kernel-level network policy with eBPF. And the examples page makes the positioning concrete, browser automation, OpenClaw integration, OpenAI agents, code interpreter flows, and SWE-Bench style training loops.
This video will demonstrate how to run a reinforcement learning example on CubeSandbox. First, on a machine with CubeSandbox installed, clone the repo and enter the directory. Next, set up the environment variable file, filling in relevant keys and configuration information. Step 3 is to create a template and enter the template ID into the end file. Once the template is created, you can use the script to start the SWE-Bench.
So the honest takeaway is simple. The tweet was only a teaser image. The real proof lives in the repo, the docs, the benchmark charts, and these walkthrough clips. If you want to dig deeper, the official GitHub and docs pages are both live right now, and the example set already shows where CubeSandbox fits in modern coding agent workflows.